Hello? Hello, can you hear me? You are muted.
Yes, I can hear you now. Sorry about that. Mhm.
So, welcome, Omar. Thanks for joining the interview today with me. Can you please introduce yourself?
Sure, thanks for having me. My name is Omar, and I was born in 1999. I studied electrical and electronic engineering here in Turkey, and I graduated in 2022. I would say about the third year of my university studying, I picked an interest in embedded systems programming. And since then, I started my journey with self-learning embedded systems. My main method for learning was reading books and then implementing the projects on them. Uh, I try my best to find a teammate to help me in the project and to collaborate with. When I find one, I work on a team to implement my projects, and when I don't have one, I implement these projects myself. After my university, I started an internship in Istanbul in a company called Border Technology on IoT projects. I had worked with several protocols, several IoT protocols like Bluetooth Low Energy and MQTT, and I implemented a small smart office project. Currently, I've been working on in a company called AirTies on network integrations, mainly on embedded Linux stuff. And that's me. That's my introduction.
Okay, cool. Okay, so I would like to discuss with you one of the problems that you have mentioned in your CV that you are
Mhm.
that you have implemented the free RTOS and real-time operating systems and stuff like that. So consider that you have a main loop and you have also an interrupt, a timer interrupt that process some data, and this data is shared between the main and the interrupt. What kind of data structure that you will use and why?
So there's a data that needs to be processed in the interrupt service routine, but also need to be shared with the main loop, right?
Yes.
So depending on the kind of the data and the type of the data would change. If it's a small
Consider,
flag,
yeah,
yeah,
consider just one integer, one integer.
yes. So if it's one integer, then it needs a protection. It needs to be mutexes need to be used for this case, so race condition wouldn't happen.
Okay, what about if you have a list of integer, an array of integer?
Uh, I wouldn't say that changes anything. You still need to protect it. Use mutexes. I can't think of a change that's necessary just because it's an array.
Okay, so for
Mhm,
example, that you have a UART serial communication interrupt, and this interrupt uh, fills a buffer, and this buffer is processed by the main loop. Is
mhm.
there any way else without mutexes that you can think of that you can use to protect the data? For example, a data structure or any other method?
Uh, if you're asking about circular buffer, yes, we can use circular buffers.
And why it helps in that case?
Because you write from one place and then you read from the other place,
And
from the other end.
how does that achieve the synchronization then?
It will only because when the circular buffer is empty, no one will be able to read it. But when you write, the reader will be notified and then you will be able to read it.
And how do you notify the reader?
I don't know. I'm not aware of the mechanism.
Okay, no worries, no worries. So
Mhm,
you have
mhm,
said that there is a synchronization primitive like a mutex. Uh,
mhm.
how can we implement a mutex if the platform doesn't have a real-time operating system?
I haven't think about that. I'm thinking about it now. One method that comes to my mind is if you have, say, we're working on an 8-bit an 8-bit microcontrollers, then updating uh, of 8-bit variables will be atomic. It will not be interrupted. Then we can use an 8-bit flag that we can use as a mutex, and we know that the updating on that flag will be atomic. Then we can use it as a mutex to do the the, the job of the mutex.
Okay, so what kind of instructions that can be used for ensuring that that it's atomic, the operation is atomic? What kind of assembly instruction that you can think of? Have you heard, for example, compare and swap, CAS?
Uh, no, I can't. I haven't heard of them. I don't know them.
Okay, so if I give you an instruction that is
Hmm.
atomic, uh,
Hmm.
and atomic, as you know, that it can be executed in one cycle, and
Yes.
if this instruction is called compare and swap, so what would it
Hmm.
compare and what would it swap if you are gonna implement a mutex or a boolean flag or something like that? How it would work?
I didn't hear the last part of the question. We have a we have an could you please repeat it? I missed the last part.
Okay, no worries. So I'm giving you an instruction, a simple instruction for that microcontroller. It is called
Hmm.
compare and swap.
Hmm.
So this is abbreviated as CAS. Okay,
Hmm.
this instruction can be executed in one cycle. So it is
Hmm.
atomic, as you know. So
Hmm.
how can we use, if I give you that instruction and a hint to you, that we
Hmm.
can, how can we implement a mutex using that instruction? What would it compare? What would it swap? Okay, for example, if we
Hmm.
have a flag that's like the
Hmm.
mutex that you wanted to implement,
Hmm.
and we can compare the current value with the previous value, okay, right?
Hmm.
And what would we swap? So this instruction
If,
can
hmm.
can check if the flag is set, right?
Hmm.
And then so it can be
Uh,
compared with one bit one, right?
uh, I can't think of the
No,
method.
no
Sorry.
worries, no worries, no
Hmm.
worries.
Hmm.
So
No.
let's go further in the
Hmm.
interview.
Hmm.
Uh, so I'm reading your CV. So give me one moment.
So,
You are saying that you are familiar with DMA-based data movements and PCI Express. Can you explain to me what did you do with PCI Express, or what is the DMA? What is the DMA and what's that?
so to be completely honest, honesty is the best here. I used the CV to apply for a job for a company that needed that kind of experience, and my plan was to prepare for it. And I specifically said that I have a limited knowledge in the CV, and my plan was to study this topic before the interview for that company. But then the company rejected me the next day, so I didn't have to study it. But
Okay,
I don't have much of knowledge about DMAs. No.
okay. So,
Hmm.
you work with MediaTek for the chipset for the network solutions or graphic solutions?
For embedded Linux solution, I use network solution specifically. MediaTek develops or gateway solutions based on embedded Linux, and my job was integrating AirTige's solution with MediaTek gateways.
Okay. So do you have a laptop right now, or we can give you a simple problem that you can think of just without writing code?
I don't have my laptop. I
Mhm.
can think of the problem if you want
Okay.
without the
So
laptop. Yeah.
so suppose that you have an array of
hmm
integers, and
hmm
this array is not sorted. So you
hmm
have 3, 1, 4, 5, and you
hmm
want to check if there are two numbers that can sum up to 8. So 3, 4, 1, 5. 3 plus 5 is
hmm
8. How
hmm
can you solve that problem and optimize it later?
Okay, so obviously the brute force solution would be a big O notation of n squared, where we go in two loops through the whole array and summing each two elements, and finding the sum. But that's not the most optimized one, I think.
Okay, so what can be, how can we optimize it later?
Can we sort the array? Is that
Yeah,
allowed?
you can sort the array.
So we can sort using quick sort. That's O in log n, and then we can start from the beginning, summing the two elements, two first element. So that would give us the smallest sum, right? So if that's larger than 8, then the problem is not solvable. There's no two elements that you can sum that you can get it, because the
Okay,
smallest two elements sum is more than 8.
yes.
Uh,
But what if the first element is 1, 3, sorry, 7, 1, 7, 8, 9. So 1 plus 7 is 8.
mhm,
So it can be solved, right? Or the
yeah.
element is at the end, and the first element is at the first position.
mhm.
So how can we proceed with with the algorithms that you already proposed now? Okay, for example, what
Mhm.
about starting from the beginning and ending
Mhm.
with the end element? So you have two indexes.
Yes. Yeah,
How can we
that's
proceed?
yeah. So if we sum the first element and the last element, that's the biggest we can get. If it's
How can it be the biggest? Because the first element is the lowest
no,
element after
sorry,
sorting.
sorry.
Mhm,
I'm sorry. It's not the biggest. No, it's not the largest.
mhm. So how can we proceed more? What about if
So
you check the
we
sum?
mhm. So if the sum is largest of of the target, we can increment the beginning index, the one from the start one.
Yes.
Sorry, the one from the last. And if it's smaller, then we can increment the one from the beginning until we get to the middle. If we get to the middle without an answer, then it's not solvable, or we will get the answer. I think that would work, I think.
Yeah. Yeah, that would
Mhm,
work actually. And
mhm.
what is the time complexity of that solution?
It's the sorting, because the sorting would take O in log n, and then the other loop is O in, so it wouldn't affect the time complexity, the last loop.
So the total complexity will be what?
O in log n.
Okay. And the
Mhm.
space complexity.
Uh, it's in place. We didn't use any additional memory.
Okay.
Mhm,
Okay.
mhm.
So you have in the CV digital communication protocols, UART, SPI. Have you seen that there is in most microcontrollers that they have a UART or SPI, they have inside
Mhm.
it a FIFO, hardware FIFO there. Do you know why it is there?
No, no, I don't know.
Okay, no worries.
Mhm.
Um, and for the C programming language, for example, if you have an array of characters
Mhm.
and it's called a string literal. So, for example, we say character asterisk str
Mhm.
equal uh, Ahmed.
Mhm.
And can we modify the first letter after saying that?
I think if you say that, it will be stored in the text section or
Mm-hmm,
somewhere that's not modifiable,
mm-hmm.
and you cannot modify it. But if you define it as an array, then it's modifiable.
Okay, so it's
Mhm.
stored in a segment or section of memory that's constant and it cannot be changed at runtime.
Yes.
Mhm. Okay.
Mhm.
So thanks for the interview. Uh,
Mhm.
بص يا عمر
Mhm.
الانترودكشن انت اتكلمت في حاجات كتيرة المفروض تختصرها
Mhm.
وتتكلم سبيسيفيكلي على اللي انت عملته. يعني انت قلت
Mhm.
ان انا خريج كذا وخريج ماشي، اوكي، دول الثلاث سطور او سطرين بالكتير قوي، وبعد كنت
Mhm.
تقول ايه بقى؟ انا ديزايند، انا اشتغلت على كذا، اشتغلت على البروتوكول ده، كتبت كذا، حليت مشاكل كذا. انا ما سالتكش ايه المشاكل اللي انت قابلتها كبيره، حليتها ازاي، الحاجات دي كلها، لان انت ما
Mhm.
كلمتنيش في الحته دي.
Mhm.
فاهمني؟
فاهم.
تاني حاجه، اللي كاتبه في السي في لازم تكون عارفه. انا عارف انت عملت ايه عشان كوالكم وكده،
Mhm.
بس يعني اللي المكتوب في السي في لازم تكون عارفه قبل كده. تمام،
Mhm.
دي احنا عارفين ليه يعني انت عملت كده.
Mhm.
تالت حاجه، ما ينفعش تقول لا. يعني لو سألك في حاجه تقول له انا عارف، مثلا انت عارف الدي ام اي مثلا، مش عارف البي سي اي اكسبريس، تقول له انا عارف الدي ام اي واستخدمت مثلا كود جاهز للبي سي اي اكسبريس. فاهمني؟ يعني تحاول ما تقولش ايه اي دونت نو، دي انا ما بحبهاش. تقول له
Mhm.
بدل ما تقول اي دونت نو اي ام ويلينج تو ليرن، انا عايز اتعلم اكتر.
نعم.
التوبيك ده لسه جديد عليا وعايز اتعلم اكتر.
نعم.
تمام، هو طبعا هو عايز يعرف الليميتيشن بتاعك، انت وصلت لحد فين في السكيلز بتاعتك. فهو اكيد هيسالك في
Mhm.
حاجات انت مش عارفها، بس انت تقول له، ما تقولوش انا مش عارفها، تقول له لا التوبيك ده جديد عليا وانا عايز اتعلمه.
تمام.
تمام. بالنسبه
Mhm.
للسترينث بتاعك، انت واضح انك انت بذلت مجهود جدا في الداتا ستراكشر والالجوريزمز. تمام. واضح جدا انك انت يعني عارف الاساسيات فيها كويس يعني، وانت فت في الحته دي، يعني انت كويس في الحته دي، يعني تقدر تعدي لو هيديك مساله هتعرف تحلها خلاص،
Mhm.
وهتعرف تجيب الكومبلكس والحاجات اللي هي الاساسيات المطلوبه في الحته دي بالذات. لكن
Mhm.
مثلا في الفيرم ورك كونسبتس انت الكومبير اند سواب، انا حاولت اديك كذا هنت كذا هنت كذا هنت، ما ينفعش تقول لي لا، ما
Mhm.
ينفعش تقول لي مش عارف. حاول تفكر، انا اديتك مساحه واديتك كذا هنت، حاول تفكر بالهنتس اللي هو
Mhm.
اداها لك. فاهمني؟
Mhm.
وما
Mhm.
تسكتش. انت سكت كتير جدا في كذا سؤال، يعني انت
أي نعم.
سكت وما بتقولش انت بتفكر في ايه.
أي نعم.
فلازم تتكلم، تقول لي الافكار بتاعتك.
نعم.
ما ينفعش تسكت وبعد كده تقوم ايه رمي لي كام كلمه، لا تقول لي لا انا فكرت مثلا في الكومبير اند سواب، انا مش عارف ان السراكشن دي ازاي تستخدم، تتكلم. طيب ممكن تدي لي
نعم.
هند، ممكن تدي لي هند، تقول لي كده،
Mhm.
ممكن تدي لي
نعم.
هند. انا اديتك من نفسي، بس انت المفروض انت تبقى انيشيتيف، انت اللي تديني
Mhm.
تقول لي اديني هند.
تمام.
تمام.
Mhm.
بالنسبه للانجليزي بتاعك انت كويس جدا، الاكسنت كويسه جدا، مفهوم كلير ممتاز.
Mhm.
بس يا عم، بس يعني انا
طيب. طيب.
آه طبعا انت الفيرم وير طبعا انت محتاج تذاكر شويه امبيدد سوفت وير وهاردوير
اي
يعني.
نعم.
يعني مثلا دي ام اي ده ما فيش امبيدد فيرم وير ما يعرفش يعني ايه دي ام اي.
اي نعم
ماشي.
صحيح يا باشمهندس، انا عندي ضعف في هذه النقطة. نعم.
ماشي والهاردوير لازم تعرف يعني ايه فيفو، حتى كنت تفكر يعني انا بقول لك فيفو تقول لي ده كيو، فالكيو ده ممكن يستخدم مثلا تقول له مثلا بستورنج الداتا مثلا، يعني ما تقولوش لا انا ما اعرفش. يعني انا قلت
مم.
لك فيفو، انت على طول تجي لك
مم.
في دماغك ده كيو، والكيو ده بيستور الداتا، تقول له مثلا
مم.
بيستور البفر. هو فايدته هنا ان هو بيستخدم مثلا لو في ديفايس مثلا بطيء شويه فهو ممكن يديله الداتا براحته. لو
مم.
المايكرو كنترولر ده بطيء شويه بيدي الداتا مثلا لحته تانيه، فالفيفو ده
نعم.
مثلا ممكن يعني هو متوصل مع مايكرو كنترولر تاني بيبعت له الداتا، والمايكرو كنترولر التاني ده ابطأ منه فممكن يديله الداتا براحته. الفيفو هياخد منه الداتا واقفه في الكيو وياخدها منه براحته، فدي فايده الداتا. بدل لو ما فيش كيو ما فيش فيفو جوه الهاردوير هيبعت له الداتا على طول يقعد يبعتها له، والتاني ده مش قادر يستقبلها لان هو بطيء.
مم.
فاهمني؟ فانت على الاقل كنت
فهمت.
تقول إن هو بيستور البفرز مثلا، بيستور بفرز، بيستور سيكونس اوف داتا او
مم.
سيكونس اوف بفرز.
مم.
بس كده.
طيب. جزاك الله خيرا باشمهندس على وقتك، متشكر جدا والله.
ولا يهمك، انا اتمنى بس تكون استفدت وتكون عرفت النقط اللي انت المفروض تظبطها.
استفدت جدا، استفدت جدا، جزاك الله خيرا
ولا
باشمهندس.
يهمك ولا يهمك.
الله
السلام
يكرمك. وعليكم السلام.